Hello everyone, welcome to my channel. This channel is designed for educational purposes, and we look at different theories of everything in general, and things that are pretty obscure that you probably wouldn't have heard of otherwise, and try to go over them in detail. And today is video number 259 on the reciprocal system of theory. Excuse me. And the reciprocal system of theory was originated by Dewey B. Larson back in the 20th century. He died back in 1990. And the general idea is that we live in a universe of motion. The universe is made out of motion, not matter, not energy, but motion. Matter and energy are merely two different varieties of motion, along with many other things. Speed we recognize as being a motion, and acceleration also. But things like force and electric current and electric charge and capacitance and resistance and magnetic flux and permeability and permittivity and trying to think of other ones here. Density, pressure. These things are all kinds of motion, and they can be identified strictly in terms of time and space. Now, what Larson says is he says that the universe is made out of motion, and motion is the relationship between space and time. So space and time is basically a fraction where time and space is the numerator, time or space is the numerator, and space or time is the denominator. But space and time can come in three or more dimensions. Really, he says three. I say three or more. But that's what Larson calls coordinate space and coordinate time. They have X, Y, Z coordinates. And he says that space and time have their scalar aspects, meaning that they are progressing. They are moving. A scalar motion is a motion that has a direction, has a magnitude, but has no direction, or really has all directions, which you would envision using a balloon and a magic marker, or a balloon with dots on it. You blow up the balloon, all the dots are moving away from each other. That's a scalar motion. They're all moving away from each other, but in no particular direction, really in all directions. That is the progression of space. We recognize in general the progression of time. Time is always getting later and later and later and later. And we began to recognize the progression of space as the Hubble telescope pointed out that all of the distant galaxies are moving away from each other, just like dots on the surface of a balloon. So Larson calls that clock time and clock space. And then in addition, space and time have the quality of being quantized, or having only discrete units. So there's a maximum unit of space, a minimum unit of space and a minimum unit of time. They're both very small, but they exist. So less than 1 unit of space and you no longer have space. Space goes to zero, and you have only time. And so too, if you have less than 1 unit of time, then you have only space. And Larson calls those the time region and the space region, respectively. If you have 1 unit of space in 1 unit of time. Now, space divided by time is speed. The bike is moving 15 miles per hour. 15 miles of space in 1 hour of time. That is speed. So if you have 1 unit of space in 1 unit of time, that is the speed of light, which Larson refers to as unit speed. Okay, so we have 3 boundaries in Larson's universe. We have the speed of light, unit speed, which divides between two separate sectors of the universe. The material sector, which is the sector where motion is less than 1 unit of speed, less than the speed of light, and the cosmic sector, where motion is faster than the speed of light. And then within each one of those sectors, you have a mini sector or a region that has a boundary of the unit space or unit time boundary. So that's, again, what Larson called the time region and the space region. The time region is within the material sector, and the space region is within the cosmic sector. And the time region is the region of atomic and molecular action less than 1 unit of space, the molecular world, and the atomic world. And then in the space region, you have really the world of antimatter, the anti-molecular and anti-atomic world, which Larson refers to as cosmic matter. Okay, and so, one thing that you need to know about the reciprocal system, time and space have a reciprocal relation with one another, but there's also, you have to understand that the reciprocal system is really a multiplicative system, whereas, the legacy science system is really additive. So with legacy science, the midpoint of something is 0. And then on the positive side, you have 1, 2, 3, 4, and 5. And on the negative side, you have negative 1, 2, 3, 4, and 5. But in the reciprocal system, the midpoint is actually not 0, but 1. So it's a midpoint of 1. And then on the positive side, you have 2, 3, 4, 5, and 6. And then on the negative side, you have 1/2, 1/3, 1/4, 1/5, and 1/6. Okay, so in the reciprocal system, the infinities are, in the legacy system, the infinities are positive infinity and negative infinity. But really, in the reciprocal system, the infinities are positive infinity and 0. 0 represents the negative infinity. 1 over infinity. Okay, now Larson took those are really, that comes out of Larson's first postulate. He published his 2 postulates in the late 1950s. The second postulate is just, it's more kind of pedestrian. The universe is subject to the laws of ordinary commutative mathematics. Its magnitudes are absolute and its geometry is Euclidean. Some of Larson's followers have kind of rejected that second postulate, including Dr. Bruce Perret, who we're going to be hearing from here. He believes that the universe is actually projective geometry, of which Euclidean geometry is just a subset. So there's some, but the first postulate is the major meat of Larson's system. And so he took those postulates and he applied them in a deductive way, like if this then that, if this then that, and he derived an entire theoretical universe from the postulates, and then kind of compared that universe with what the legacy scientists had already come up with. And really 90% of what Larson came up with was already in full agreement with the legacy scientists. It was only like the 10% of stuff where he made adjustments, and that stuff was mainly in the realms of the very small, the very large, the very fast, and the very slow. And just like Einstein's adjustments of Newtonian mechanics, Einstein he agreed with Newtonian mechanics in general, but in the extremes is where Einstein's relativistic approach yielded differences from the Newtonian mechanics. And this is the same way with Larson. And that's why Larson has a book that's called Beyond Newton. He's basically, saying that Newton is basically correct, except on the margins. But Einstein is not correct. He's basically adjusting Einstein. Now, he accepted the idea of E equals mc squared, but the relativistic stuff he rejected, and he replaced with different ideas about those things. And a lot of that comes from, these things like the time region and the space region, things like the interregional ratio, which we will eventually go over as well. So Larson died in 1990, and after he died, some of his followers kept continuing his work and expanding it into other areas. One of the greatest of those was Dr. Bruce Perret, who also just recently passed away. But he wrote many articles and had a few websites dedicated to what he called RS2, the re-evaluation of the reciprocal system. So he took Larson's stuff and he made a few, tweaks to it, particular having to do with the photon, having to do with the geometry, having to do with some of the scale in astronomy. That's kind of what we're looking at here in this article. We're looking at an article that is the fourth in a series that he calls Anthropology, the hidden history or the hidden origins of Homo sapiens. And this is the fourth and last one of those articles. We've been going over this for about a month. So you can go back to the first one of the Daniel papers. Dr. Perret wrote under this pseudonym Daniel Phoenix 3. And so we're going to start here. This is the second day of doing this. So if you just want to go back and get the beginning of this particular article, just watch yesterday's video, and then you'll be ready to start with today. Now, he had just got done discussing parallax, and he's trying to kind of reformulate the astronomical scales. And he's really saying that, okay, legacy science says that the Andromeda galaxy is 2 million light years away. That's totally impossible. And that doesn't match up with the way that I understand the reciprocal system. And that all of these distant galaxies that the legacy science, says that they're millions or even billions of light years away, are actually much, much less than that. And they not only are they not too distant, they're all within three or 4,000 light years at the most, and um, they are not galaxies, but they are solar systems. So they are a sun with some planets rotating around them. And so that's what he's saying, is that he feels that, according to the way he's understanding things, and he borrows from this guy Bahram Katarai, another astronomer, who wrote a book called Revolution in Astronomy. Also wrote a book called Revolution in Physics, which I haven't got my hands on yet. But so we're going to start here with Dr. Perret. But the gravitational limit, a concept unknown to modern astronomy, was not taken into account. Space was assumed to be three-dimensional and homogeneous everywhere, which is actually not the case. Studies of globular clusters, studies into globular clusters and galaxies reveal that the system moves like a viscous fluid or hot solid, not objects floating around like gas molecules in a void. All the stars and nebula appear to be bound together rather tightly. Galaxies appear to have much the same structure and behavior as the resulting whirlpool in your sink when you pull the plug on the drain. Now, this gets into this concept in the reciprocal system called the states of matter: solid, liquid, vapor, and gas. And, possibly what Larson calls it condensed gas. But that is kind of a fascinating study. But he's basically saying that even though galaxies appear to be, these spread out things that are mostly empty space, in reality they behave as if they're a liquid or a solid. Okay, this observation provides an opportunity to understand the effect of the gravitational limit on what we see. In essence, the 3D region inside the gravitational limit has a structure similar to a clear liquid, whereas the region outside the limit is more like a gas. Basically, kind of meaning that the limit is more or less the boiling point. Something to that effect. We now have a simple analogy to understand what is going on. Jump in a pond and look up at the objects in the air. If you've ever been diving or swimming off a boat, you may be familiar with the problem of the index of refraction. If you approach a boat from underwater, reach out with your hand and try to grab a rung on the ladder on the side of the boat. You miss because the rung isn't where you see it. When light moves between mediums of different density, such as the air and the water, it bends or refracts but your arm does not. So the same problem occurs when trying to catch fish with your hands standing in water. You clearly see the fish, grab for it, and miss because the image of the fish isn't where the fish actually is. This is exactly what is happening between the 3D water space inside the gravitational limit and the 2D air space outside the limit. The stars we see in space aren't where we think they are. The actual object is much closer than we observe it to be, which has led to those miscalculations of distance. And he has a few graphs here. It basically shows that, the light bends. And so, when it goes into a different medium, it bends. And so that means that, what we see in a straight line, or things actually are occurring in a straight line, but what we see is the result of the bending. And so what we see is actually not in the same place as where it actually is. Okay. This section is called Astronomy 2.0. And we're just going to read a couple paragraphs here just to get started. So, where does that leave astronomy if what we've been told is wrong? In essence, astronomers have been looking at the universe through a fisheye lens that has been magnifying things out of all proportion. Add that to the backwards evolutionary processes, and, well, you can see the trouble this science is in. But here is what we do know. The objects within our solar system have been measured to a reasonable degree of accuracy. In the reciprocal system, everything works the same way. So what we see in our solar system is probably typical of other solar systems, as well as both larger and smaller constructs. By that, I mean, if you look at our solar system, you find a collection of planets in a roughly planar orbit, asteroid and Kuiper belts, and at a far distance, the Oort cloud, forming a sphere of debris around the system. Now compare that to Jupiter, a miniature version of a solar system. Again, you have moons in a roughly planar orbit, ring systems that are belts, and at a far distance, small asteroids and moonlets orbiting around the planet in a roughly spherical distribution. The Jupiter system is just our solar system in miniature, a scaled down version. And this is the situation we find with the observed stars, so-called stars, and so-called galaxies. When we scale them down, we find that stars are actually Jupiter-class gas giant planets, and galaxies are actually solar systems. As revealed by Hubble photographs, the cores of galaxies appear as single stars, sometimes doubles or multiples, but mostly single. The encircling cloud of the Milky Way galaxy is just the outer rim of our solar system, not an independent object. This is also evidenced by the difficult time astronomers have had trying to find the core of the Milky Way galaxy. Eventually, they decided it was in Sagittarius, SGRA, because that spot was lit up a bit more than the rest. But if you take a look at this artist's conception of what our solar system, and then compare to an actual photo of the Sombrero galaxy, which he does right here, and the sun is kind of a little bulge in the center, and then there are certain other areas that are kind of defined. If you have ever seen a picture of the Sombrero galaxy before, and someone came along and showed you this photo stating that the Hubble found a new solar system, you'd probably believe it without question, because it looks exactly like a solar system, not a galaxy. Bring up your favorite search engine and take a look at the Hubble Space Telescope photographs of galaxies in all their remarkable detail. Then ask yourself, am I looking at a galaxy or a newly forming solar system? Check the details. The galactic core looks like a single sun, complete with a defined disk. Asteroid belts are commonplace, along with a lot of dust and debris. What Larson says provides the fuel to power the sun through atomic fission. Our sun is older than most of these others, hence it has digested most of the debris that would be found between the planets. Of course, the planets also accumulate dust and debris. The Earth alone sucks in about 100,000 metric tons of a cosmic dust every year, and that is low because most of the dust and debris has already been captured. Observation has come a long way since the early black and white photographs. As resolution improves, what was once thought to be light from millions of stars is now seen as luminous gas clouds. Nebula become sharp and defined, and the large blob that was once the galactic core has significantly reduced in size to a small sphere. As resolution improves, the core will probably become smaller and more defined until it looks exactly like the sun it may well be. Okay, we're going to stop it off there and resume in the spot starting tomorrow. Thank you for tuning in today, and have a nice day.